Okay, let's see if I can make this video a little shorter than the one on the 7 modern perspectives. I want to help you with the research topics of correlations, the different types of correlations and what correlations mean, versus experimentation. What is an experiment? What are the parts of an experiment? How is a good experiment done? And the main difference between correlations and experiments is that experimentation is the only research method that can show you whether one variable is actually causing another variable to change, whether there is a cause and effect relationship between two variables. In other words, where's my cell phone? Do cell phones cause brain problems? Does the radiation emitted by cell phones cause brain problems? The only way to answer that question is to do an experiment, and an experiment has to have at least 2 groups of subjects, a control group and an experimental group. Subjects are randomly chosen and randomly assigned to be in one of those 2 groups, the control group or the experimental group. The experimental group is exposed to the independent variable that you are testing to see if it actually causes something to change. So the independent variable in this experiment is cell phone radiation, exposure to actual radiation. Now we might have different levels of radiation, but subjects who are actually exposed to radiation from cell phones would be in the experimental group. The control group would be given cell phones, but we would have to manipulate the cell phones so that they were not emitting radiation. I don't know how you do that. Maybe you turn the phone off and you have people hold it up for as many minutes a day as people who are talking on their live cell phones. But you would have to have a control group where they're exposed to cell phones but not the radiation. You see what I mean? Or it has to be something that's almost exactly like the experimental group, but missing the critical component, which would be the radiation, correct? So in this experiment, you would have a control group who's got cell phones, but without the radiation being emitted, and then the experimental group would get the cell phones with the radiation emitted. Now, how are you going to compare those 2 groups? On some outcome, some measurement of outcome. You'd probably have to have a pre and post brain scan. You're going to take brain readings. You're going to take EEG readings. You're going to do positometry. You're going to do all these brain studies on both groups of subjects before and after exposure to the radiation, or before and after the control group exposure without radiation. The measurement that you're collecting, the brain scans, would be the dependent variable. The dependent variable is always some measurement of outcome. Was there an effect caused by the independent variable? Did the radiation from cell phones cause an increase in brain abnormality? So you have to have some measurement of brain abnormality. That's the independent variable. The measurement of outcome is the dependent variable. The independent variable is the variable that's being manipulated by the experimenter, meaning me. I'm manipulating which group of subjects gets the radiation and which group of subjects gets no radiation. Does that make sense? The control group sometimes gets a placebo, which means it looks exactly and smells exactly and feels exactly like the real experimental treatment, but it's missing some critical component. For instance, the cell phone without the radiation could be considered a placebo. It doesn't have that critical component of radiation. You've heard of sugar pills? Sugar pills are placebos without the active ingredient that we're testing. let's say we're measuring, let's say we want to test the effect of caffeine on study skills, on test, and we're going to use test scores as a measurement. Do people who drink 6 12-ounce Diet Cokes a day, do they tend to score better on the exam than people who did not drink 6 12-ounce Diet Cokes a day? I'm bringing that up because I'm a Diet Coke addict. I'm not proud of that. It's just, that's my vice. Anyway, I don't drink coffee because I had a horrible aversion experience of, I thought I was putting sugar in coffee when I was 4 years old. I put salt in the coffee and my dad made me drink it because his generation, you didn't waste anything. You're not going to waste a cup of coffee that costs 5 cents. You're going to drink it. So I can never drink coffee again after that, after drinking coffee with salt in it. Can you imagine? Oh. Anyway, so an experiment has to have at least 2 groups of subjects that are treated differently. One's a control group, what's an experimental group? The independent variable is the thing you're manipulating to see if it causes a difference in an outcome measurement of some kind, and that's the dependent variable. Okay, let's talk about correlations. Correlations cannot tell you if one variable is causing another variable to change. Only experiments can do that. But what correlations do tell you is if these 2 factors or variables tend to be occurring at the same time or not. Do these 2 things tend to go together, or do they tend to not ever go together? And we can use correlations to help us predict future behavior. Correlations can be found in data gathered through surveys, questionnaires, or observational data. The most common way to look for correlations is to sift through survey questions and see if there is a statistical relationship between any 2 questions. So in my live classes, I typically give a questionnaire to all the students, and they circle an answer between 1 and 10, indicating their answer to each question. And the questions have to do with all kinds of random things about your background. The first question is scoring yourself between 1 and 10 on how extroverted you are in your adult personality. And if you're a real big extrovert like I am, you would circle toward a 10. And if you were really shy and introverted, you would circle toward the 1. And if you're neither, you're just in between. The second question is, it's the same question. How extroverted were you when you were a child? And so again, you would circle between 1 and 10. Now for me personally, I was a 10 in childhood and in adulthood. I was always a show-off, always seeking attention. Look at me, look what I can do. I do splits and cartwheels and gymnastics just to get everybody's attention. And back in my day, we had to wear dresses to school. So in elementary school, I was doing cartwheels all over the place, showing my panties. So everybody would look at me, I guess. I don't know. Anyway, it was a great day when they allowed girls to wear pants to school, so we could do tricks and stuff without being inappropriate. So, is there a correlation between the way people answer question number 1 and the way they answer question number 2? In other words, do the people who score high on extroversion as an adult, do they also tend to score high in extroversion as a child? In other words, do most people tend to stay the same? If they were extroverts in childhood, do they tend to remain extroverts as adults? Or is it more often like a switch? People who were shy in childhood tend to become more extroverted as adults. People who were extroverted as children tend to become more shy as adults. Well, which is it? Do the high scores in childhood tend to go with high scores in adulthood? Low scores in childhood tend to go with low scores in adulthood? that would be a positive correlation. The direction of the relationship is the same direction. Highs go with highs, lows go with lows. That's a positive correlation. If we did find a positive correlation between those two survey questions, we would draw the conclusion that not for 100% of the population, but the majority of people surveyed tended to retain their level of extroversion from childhood to adulthood. Those who were highs tended to score high on both questions. Those who were low tended to score low on both questions, meaning they remained shy or they remained extroverted. A negative correlation means there was a switch. A low score on one question was associated with a high score on the second question, so that lows went with highs. So it went like this, right? Highs went with lows, or lows went with highs, like that. They go in opposite directions. In a positive correlation, the scores go in the same direction. Highs go with highs, lows go with lows. Same direction. The possible scores are between negative 1.0 and positive 1.0 when you do the statistical analysis. And your textbook gives you a range of values, anything between negative 0.1 and positive 0.1. The positive values, of course, indicate a positive correlation. The negative values indicate a negative correlation. Anyway, that was just a quick example, okay? What about how much TV you watch and your GPA? What if I do have two questions on the survey. How much TV do you watch? High or low score, 1 to 10. And what's your GPA? Low to high on a scale of 1 to 10. Do people who tend to watch a lot of TV, scoring high on TV watching, do they tend to have the highest GPAs? If so, that's a positive correlation, meaning highs go with highs. Those who watch very little TV have low GPAs. They're the same. What do you think? Actually, I have gathered that data from my classes, and it turns out those who watch the least TV tend to have the higher GPAs. So that means low scores are associated with high scores on those two questions. Lows go with highs, and highs go with lows. So what kind of correlational relationship is that? That's a negative correlation. Anyway, just a couple of examples to, help you understand the difference between correlations and experimentation. Remember, experiments are the only way to determine if a cause and effect relationship is occurring. Not just a relationship of positive or negative, but a causal relationship. Causation can only be addressed by a well-controlled experiment. Okay, thanks for watching.